Hi, IT 380. This is the first week of the class, and I'm going to give you a primer on just the basics, the foundations of this field. So, educational psychology, learning science, maybe a bit of pedagogy. On the screen right now is the related works section of my own dissertation, the research I've done into educational technology. And I was hunting around on websites and trying to say, what might be the best way to introduce the students to the ideas in this class before we actually start to dive in and talk about educational technology, our user experience terms, our human-computer interaction terms, and how the overlay of software design and software engineering interface with education and create this field of education technology. So this is the related work section of my PhD dissertation. Related works and research is showing that you've gone off and you've read all the literature related to what you're trying to research, that you're not off in left field by yourself, that there is a lot of grounding research has been done before you, and that there are interesting areas that have yet to be examined, which means that your research area is worthwhile. So a lot of my related work talks about these kind of grounding areas of learning science, educational psychology, and then leads into the benefits of educational technology, specifically within STEM education. Obviously, we can look when you wish to pick a topic, and education technology is helpful to all education, including other areas such as liberal science, or liberal arts, and humanities. It's just that we happen to be in a STEM school with NJT, and my focus was on computer science and STEM education. So, learning science is a very hybrid field. It's actually very similar to, instead of saying user experience and human-computer interaction, which are very similar fields, they talk about the design side of software. Learning science is very similar to UX and HCI. So actually this class is very beneficial to just general software design and engineering principles as well. And the better that you can ground a computer user in your software, using these learning principles will help you with your other pieces of software that you build. That's why games have like a tutorial level at the beginning. You have to train the user in your interactions and the computer input that you've designed for either your game, your simulation, or your software. So these kind of are universal. There's a lot of overlap. So the field of learning science is very hybrid. It hits upon psychology. It hits upon, when I say pedagogy is the science of teaching. So it hits upon pedagogy. It hits upon educational technology and software design. It hits upon anything that's needed to figure out the human psychology that's necessary for development and learning and teaching of people. So technology is super useful in this field. Obviously, the traditional methods of lecture or teaching are just a passive component where the student sits back and just listens to somebody who's just a little bit more experienced in trying to break down the knowledge area in a simpler way so that it's easier to understand and build up the own student's understanding. Actually, that is a big educational theory in the field, and it's called Constructivism. And it's the idea that the learner is active in building the thoughts, building the understanding in their own head. So you're going to get students or learners or users of your software that are of all ages, of all different experiences, understandings specifically to the domain that you're trying to teach, different emotional backgrounds, and they bring a lot to the table when they're trying to learn in this kind of bi-directional relationship where you're trying to teach. So in this class, I'm going to be the teacher, you're the learner, but you're trying to learn to become a teacher. You're learning how to make your own educational technology to teach something. And so the big people in the field, anyway, in this section that we'll focus on in this class, we'll use the educational theory of constructivism, which is also the primary theory that's also used in learning science. And one is the kind of the individual cognitive constructivism, which is focuses on the individual, what I was previously talking about, what you bring to the table, how you build your own thoughts. Even a very passive mode of lecture, in this case through a video, technically you could say that this video is educational technology. It's just a very simple form of it. It's a very passive form for the learner. But you're still sitting there and actively absorbing sensory information into your head. You have the visual information coming through the monitor screen to your eyes. In this case, it's a static image, not much going on, but you're probably reading the text that's on the screen as I'm talking, and you're finding interesting or trying to find something of interest in the writing as I'm talking. So you're receiving visual information as you're listening to me. You're having audio information coming through the speakers that are going through your ears, turning into electrical signals in your neurons. And this I'm using a language that's developed called English, and most of you, this is your primary language, or maybe it's your secondary language, but you can understand the ideas that I'm trying to express through my mouth, through your ears, and trying to form these ideas in your head of building this class, this structure of knowledge that this class is meant to present to you. And so we're just in the primer area. We're just in the basic area. I'm trying to give you some basic building blocks of ideas to start to build more complicated ideas and actually build pieces of technology later on in the class. So you can see that I just kind of expressed the psychological notions of constructivism. And actually, I was also expressing the ideas of sensory information and input devices and input senses on your side through to your cognition. So I've actually started to interlace the ideas of UX or HCI with learning science. And so when you think of input hardware from the computer or output, we're already actually kind of moving ahead into these HCI frameworks where we'll talk about the software side of it. But in any case, we have the individual, yourself, building knowledge in your head that I'm trying to make it the most fluid, smooth process to build these ideas. So this is the idea of constructivism. You are the active builder, the active construction of building these abstract ideas in your head. And the class is supposed to be the structured time that you can do it as best as possible. So we have this idea of learning and practicing. I do have this one graph. I'm just going to bring this over. So I have a lot of these presentations that I'm actually going to assign some of my presentations of the research we've done. Not only I think it does a good job of explaining educational technology, but it's like a full cycle of research on Edtech that you can at least start to see the bigger process of research, design, development, and cycling over and over in that. But in any case, this is a good graph to show what I was talking about with constructivism, which is the individual or the cognitive form as Pi got. And it's we have a concrete experience. This is from the user's perspective. So there's some type of experience. You have some type of sensory information. Usually it's a combination of visual, auditory, maybe haptic, maybe feelings, a sense of temperature, a sense of pressure. Maybe you're actively doing something like learning how to do woodworking, or some type of trade, or even programming, you have that tactile response. You do have to learn how to use a keyboard and interface with your hands as you're thinking about your programming. So there's also this idea of a haptic or a tactile element of the experience. And then obviously the abstract, what's going on in your head, your sensory information being turned into your cognition, your thoughts. Then you make decisions or actions or behavior based on that. So there's some experience given to the learner. In this case, a passive educational technology called a video that a lecture is happening. You are having observation. You're observing this and you're reflecting on it. What do you think about it? You are actively building these thoughts, and it's a very iterative cycle in your own head of trying to match your own inner logic, your own inner ideas and cognitions to what I'm talking about, and you keep kind of adjusting and adjusting your ideas to what I'm saying. Sometimes the lecture the learner might be in a disagreement to, and you're just not able to align your thoughts to it. But more general, these are in the normal sense of general education, whether it's art or science. The learner, it's a pretty, not an argumentative or a controversial idea I'm trying to teach. These are ideas that more than likely you're observing, you're listening to me, and you're reflecting, you're adjusting your inner ideas to me. And there's not a cognitive dissonance. You're not in disagreement with me. So you're reflecting, adjusting, observing, and we go on, and you're forming these abstract concepts, which I was talking about, forming these ideas in your head, hopefully in agreement with me. After learning, you practice, you test these in new situations. So especially in the technology schools, we are all project-oriented classes. And I'm going to be building a project for this semester. I'm going to be showcasing previous projects that we've worked on. Mostly this Espresso, using virtual reality to teach computer science and math concepts to younger students. But I will be building, going through all the phases that you will be in this new project that Jess is working on with Hannah over in COAD that you might know, called the KNID project. And so we'll do a very small cycle of research, design, and prototype along with you of the same scale and scope. So hopefully it's easy to follow along, yet with your own idea. So anyway, you're going to be testing in a new situation. Practice is always, fraught with, I'm going to right off the bat say failure. And it's not a bad word. It's a very good word. It means you're going to learn. So, you fail 1,000 times before you succeed, Edison said with the light bulb. And so that's good. We want that. We want practice. You're going to go through all these rabbit holes and tangents of thinking and testing and prototyping. And you're going to come out with something at the end of the class. And you'll be able to build a portfolio piece around it. And it's okay if you made some wrong decisions or inaccurate or what you think in hindsight at the end of the class might have been like, well, I feel like I could have made a better choice at that point. That kind of led me down a different path when I finished up my prototype. It's okay. It's still a very worthwhile process, and you will still have a great portfolio piece, and you can return back to it and just go through the cycle again at a later point with even stronger skills and make stronger portfolio pieces. So anyway, you will be testing, and we return back to another experience. So we either have to return to the same learning point if you need another cycle of learning and practice before you get it, or we move on to another point, maybe a more advanced point that we first needed to cover the beginner point, or we go on to another topic, or maybe you have a question and we explore an area that you're interested in. But as you can see, life itself is very iterative. The learning process is very iterative, and that's why software development itself is also very iterative nature to it. So all of it we're always cycling on. In fact, I'm going to so this was with Pygo with individual constructivism. I'm going to talk about Vygotsky in a second. but those are like the two main guys. There's hundreds. So many people have added to this field. But as long as we ground you in Pygo and Vygotsky, you're good. We have individual constructivism, and we're going to talk about an element of social constructivism. But in this case, I was kind of talking about these cyclings, and I want to just touch briefly on, we could talk about the educational technology cycle, how it reflects over into this side. It reflects over into the hardware and software side, so that you might be able to look out a bit further and where this class might go. But we will be using what will be called the user system loop framework. It's very useful I found it very useful in my research. It is a 3D user interface framework, and I've used it for augmented virtual reality. But I like how it breaks down the interface between the user psychology and the computer processing side. So it's also very viable for 2D as well. And in a moment, I'll talk about the bottom area. It relates well to the simulations you're going to have to build for educational technology. But anyway, at the top, we have the user. The user will be expressing some actions. They'll either use their hands on the keyboard, they'll use their hands on the mouse, they'll use their hands on a touch screen, or nowadays, with hand tracking, is just doing hand movements in the air. They might talk, there might be voice recognition software, or whatever. The user uses their body in some way to produce an action onto an input device on the computer side. And it might be a keyboard, a mouse, a touch screen, sensors looking at the hands, a microphone picking up their voice, or whatever. The input device processes all this, usually analog data, real-world data, into some digital format. It does some transfer function, creates some data that's useful for the computer to process on. And this side is called the interaction fidelity. This is the interaction design area, and this is where we'll be focusing a large part of the class, how to design your interactions so that they're useful, easy to understand, yet expressive for the user as they go through the learning process. And then their commands are done upon the computer program. The computer updates the backend. You could think of this almost as a model view controller design, MVC design. And if that's new to you too, we'll have a separate video on that. But this can be thought of as the controller side. The user has a controller element, is giving commands. So it's giving control to manipulate the computer side, the back end side, or the model side, where we're going to model a piece of reality, meaning we're going to simulate something. So in this project we're looking at, we're going to simulate a piece of ecological geography. We're going to where these populations of canids are living. So we're going to model a piece of reality or simulate it. That simulation can be adjusted, manipulated, affected by user actions on this side, on the interaction side. And this is our scenario fidelity. How fidelity meaning like how much of reality do we have to recreate in our simulation that's a fertile ground for the user to learn something. Once the simulation is updated, we will update our rendering software. We'll update our visuals, or if there's any audio, maybe there's haptic feedback with hand controllers. But usually, in this class, it's going to be primarily visual. It's going to be computer graphics rendered onto a monitor, which is our output device, and that creates sensory information or stimulus back to the user. Again, we have our full feedback loop. The user has new information coming through their eyes, through their ears, maybe through their hands, that allows them to change their thoughts, have cognition, allows them to make decisions and implement an action that changes the simulation, that changes the sensory data, the stimulus back to the user. And this continues hopefully until we have a successful, happy learning process happening, and the user or the learner is happy in learning, and it's a fun, engaged experience. So you can see at the learning process, this feedback loop on the learning process, this feedback loop on the technology side is very similar. And that's why we reflect upon these two processes in educational technology. And hopefully you can see why educational technology might be so important, so impactful, is that it almost encapsulates this learning process without the need of another person. So you can automate it. It's very tiring and to learn how to be a good instructor. Hopefully I'm having a good job in this class. And it's tiring, but it's very rewarding to learn how to be a teacher, but you have to do it over and over again per class, which is actually why I'm making this video. I'm actually automating my learning, my teaching processes to the learner's learning processes by creating this video that can be watched over and over again. You can pause it, you can return back to it, you can go take a break, you can reflect, and you can watch it at later dates, and I can reuse it in other classes. And so I'm taking advantage of educational technology for these benefits, and this is what you'll be learning to do as well. So I did want to return back to Vygotsky and finish this lecture on the basics of learning science. So I'm going to ground out all of pedagogy and educational psychology and all of this. I'm just going to wrap it up into learning science. And within learning science, that's why learning science exists, because there's so much to education, so many facets to it, especially when you bring in the idea of technology. And so they have this very big hybrid field called learning science. And within learning science, we're just going to focus on the idea of constructivism as the psychological theory of how learning works. And we just covered the individual side with Paget. Pego, I right the moment. I'm sorry, I'm just tired with this baby. I can't remember the pronunciation of his name. And then Vygotsky. We have the social cultural perspective as well. So it's interesting to note that I think I'm also going to just cut out the related work section of my thesis. The dissertation hasn't been published yet, so I can't give you the PDF, but I'm going to cut out the related work section and post that up for you to peruse on your own time. And actually, that is another piece of educational technology. Just kind of as passive, it's at your own leisure. You can read through a document, right? And it's a file presented on a computer that can have text and images and maybe even moving parts like a video or an animated GIF with it. But we'll be doing more interactive simulations. You can gamify it as much as you want, and we are going to be talking a lot about game design. But I'm going to steer away from the term educational games, and it's more about educational software or educational technology, because we're going to pull in everything. And at the end of the day, it's supposed to be engaging and really fun, and we're going to use a lot of ideas for games, but it is a learning situation, and it's serious, and so we're going to call it educational software. But in any case, Vygotsky took a different perspective than Paget, and it's not one or the other. It's the fact that, yes, the learner is self-determined, is individualistic, and you're responsible for building your own neural pathways in your head and maintaining them over your lifetime to be an educated person, but you're also immersed and surrounded and cannot avoid culture and society. All of our learnings are through a cultural format. You learn to talk, you learn to speak, you learn to listen, you learn to see, act, all these rules of society. Everything we learned, all these knowledge domains that we're teaching of education, math and science and language and history, all of this is cultural. And so you cannot separate the learner from their society, from their social surroundings. And so Vygotsky really focused on that. In fact, here you could say that I am transmitting information to you, and you're sitting in this remote location all by yourself and listening to these electric instruments on your desktop, these speakers vibrating, causing the molecules in the air to vibrate against your eardrum. And these electrical signals that are produced, your brain has been trained culturally to understand certain ideas that you're hearing as words combined together in sentences and larger ideas. And the fact that this video is also turning on all these millions of pixels on your screen at different brightness and hues, colors, to create this cohesive image. It's actually not a cohesive image. It's all these pixels sending out all these different light waves of different wavelengths that your eyes are processing, that together inside your head somehow gets formed together into this picture that's presented to you out in reality, that's on a plane on your computer, that your brain is processing into an image that of, in this case, very simple, white and black, and these weird little wiggle lines and edgings of black on white. Your brain can discern from previous learnings, the previous changes in your neural network can process these black squiggles into words that you read together, that you process into sentences. So in the same way that I'm talking and you're processing the audio signals into words and piecing them together into sentences, the same that these black squiggles you're piecing together into letters, into words, into sentences, into larger ideas. And all of that, I just went off on this crazy tangent about technology interfacing with real world physics, interfacing with your body organs, sensory organs into your brain, the cognitive organ, and all that having to deal with a cultural slant on it. All of that is this electromagnetic physical phenomena out in reality that was trained by human society to mean certain words, certain ideas. Even the idea of language is just these ideas in your head. But all of that is cultural. All of that is social. All of that's been trained onto you since birth. So you come into my classroom with 18, 19, 20 years of being trained culturally. And, I aggregate, I make a stereotype of where I think the average student is and what the point of this class is. And I try to cater to the average, the biggest part of the class, but obviously we're going to have a lot of outliers, and that's why we have lab time and to corral everybody together and give everyone as best experience they can, because they're all coming from different cultural backgrounds. So you can think of them as individually having all these backgrounds, and oh my god, I have all these students and they're all different, but they all are a sophomore or a junior within either IT or CS or DD at NGIT. So I can kind of think about your cultural and social backgrounds and where you should kind of be at from an individual perspective, a cognitive constructivism, or from a cultural perspective, from a social constructivism, and that's Vygotsky. So there are different frameworks, there are different lenses to think about a learner and to think about how to approach them, to think about how to develop some educational material to present to them, and to try to minimize, like lost cases or worst case scenarios where you're just way off the mark. You didn't hit them directly with your approach, with your technology to educate them in some way. So hopefully that all made sense, and that there's these two ways of viewing people, from an individual, from almost like a neural net perspective, and from also this cultural, that everything's been trained through the mind, and that you have to deal with somebody within their cultural context, and people learn best with this cultural context, being socially around, that you need to be immersed in talking, that you're listening to me, but you're turning to somebody next to you and you're talking to them, and you're trying to use your own social interactions to help solidify the learning topic in your head. So it's almost like a practice part. So if I open, let me just find that one window again. Yeah. So you can think about this from the individual practicing, so trying new code, new interaction ideas, trying to think about these educational theories and then apply them in an area that you like. Say, oh, I really loved 8th grade biology. I want to do a little sample lesson in there or whatever. Now that's from a individual constructivism, the Piaget perspective, or you can think about students interacting with others and trying to form their own ideas and verbalize what they've just learned to somebody else, to their parents, to their friends, to their colleagues in the classroom, to kind of ground themselves in the knowledge in a social way, in a cultural way. And that also is this section. They're practicing the knowledge, but in a more cultural or social way. So there's many, even just looking at these two, an individual or a social perspective on cognitive constructivism or just cognition, the process of learning. You can look at it from the teaching side, you can look at it from the learner side, but it's important to always kind of have two eyes, the individual eye, the social eye, because you can't avoid our cultural. There's no person, there's no I. It's we and the person. That's just our reality. So let me move on. So another section in related works talks about cognitive models in human-computer interaction. So I kind of briefly showed you that user system loop, but now I try to approach the ideas of education, learning, from a psychological, a human-oriented side. And this section actually tries to approach the software side, software and hardware, the computer side, the technology side, the educational technology side, from the psychological, from the human-oriented side as well. So if you are interested in HCI or UX, you'll hear these terms a lot: human-centric, human-centered, human-oriented. In fact, the term human-computer interaction in the field focuses on the human side when a person interacts with a piece of technology, with a computer. There's no point to any of this technology, any of these computers, without the how they're aiding, interfacing with the human. So it's a big part of it as well. And that's why we have these feedback loops as graphics, as ideas to talk about education and to talk about technology together, Edtech. In this section, I kind of covered this all with, HCI side. I'll probably talk more in I'll probably cover this more formally in another section, but this being the first week, I kind of glazed over it. There's the user, the human, the psychological side. You produce actions on the hardware. The hardware transfers that information into something that's useful for the computer to manipulate the simulation, to update the visuals and audio and haptic through hardware output devices back to the user, and we cycle. All this might be happening in a very small fraction of a second, so the user sees this as a continuous, seamless process. But the monitors and the speakers are all processing out very discrete movements that are so small and quick that over time the user feels like a seamless experience. So I just moved to the next page. Principles of embodiment. Okay, so this actually might be interesting to talk of. I talked about this more, about the stronger benefits of AR/VR, but let's talk about this for a little bit. So we talked about You can't separate like the mind or the individual person from the learning experience. You can't separate their culture, their social surroundings from the learning experience. And now this says you can't separate the body. So embodiment, and there's a term in the learning science called embodied cognition, and there's a similar term in HCI called embodied interaction. And so this idea of embodiment means that everything we're talking about, if you notice all my rants talking about these physical processes dealing between the computer hardware and the person, these electromagnetic waves and the deciphering of what that means through all these cells and the sensory organs of the human body through to the mind, we're talking about this idea of a physical reality. All of our learnings are really about this, what's going on around us. What is this world? What am I in it? And what do I need to learn to function within this physical world, this natural world, this human world? And you can't really separate this idea of a body from the learning process. So, and from the computer interaction process. Learning is in depth with the sensory information. Again, the eyes, the ears, the nose with smell, the whole skin with feeling. And feeling might be broken down into like temperature and humidity and pressure, the feeling of gravity, and what have you. So we have this idea of embodied cognition in learning sciences, that you must think about the body and learners' physical surroundings in their physical body when approaching a learning topic, and even in topics as abstract as mathematics and computer science and physics, but even a science like biology. I mean, we're talking about cells in the body. It's imbued in the topic. But think about moving to areas of applied sciences like engineering, mechanical engineering, and chemical engineering, industrial engineering, and thinking about moving to trades like woodworking, or auto repair, or carpenter. These are learnings that the more hands-on that you must either. You can't just sit there and watch. You can't do that in any learning discipline, but there's no way you're going to learn to be a carpenter without understanding how to use your hands, or a musician, or artist, or anything, any type of, I guess if you look at learning where you're trying to give them a career or something to do, like gardening or sewing, which you might not think as a career, but it's an activity that you can't pull away from the hands or the body. All of these learning topics are like, even reading, you think there's nothing to it. You still have to understand how to like move your eyes across the page. You still have to understand how to flip a page. You still have to understand how to hold your body as you're reading, ergonomics so that it's comfortable. All of this comes into the play as well. So we have this interesting connection between learning science and HCI fields as well, with this principles of embodiment. So I just talked a bit about embodied cognition, and you have to think about it as you're developing education or learning scenarios. But now across into the field of HCI is this idea of embodied interaction. So interacting with computer systems that occupy our world. I'm over here right now. And again, we have this world of a physical and social reality, and we're always going to be interacting through it with the learning process, and just life itself just happens to be in this type of reality. So all of our learning and education and technology use cases have to be there as well. And so embodied interaction is kind of a broad, loose term. It can mean a few things. It can mean like, oh, you have this computer system set out where physical objects in the world actually interface with the computer system. So if an elevator is run by some type of embedded computer system, actually pushing the buttons on the elevator is embodied interaction, because you're thinking, this is a physical object, I'm pushing it, I'm going to go to floor 2. But when you push that button, it's sending some type of signal, some type of computer system that is running the elevator system. So you're actually interfacing with a physical object that is actually interfacing with a computer system, which these days, it's getting harder and harder to step away from it. So even like the low front of your refrigerator might have a digital display, and you can change ice cubes to water, and you push your glass on that lever, and it releases either water or ice chips. Where most of these systems might be like purely mechanical, not have an electrical or computer system come onto it many years ago. Now a lot of these things have small computer systems, these embedded computing systems. That's why Internet of Technology, IoT, is such a hot field. And this is, you're interacting with a physical object, which is interacting with a computer system. But there's another part of embodied interaction. Now think about, you're manipulating physical objects. They can be virtual representations of the physical objects. So I'm just going to bring over slideshow quickly. This is the binary math. But if you think about the fact that the student is in virtual reality with this hand controller, now you don't even need controllers, just the basic hands, but they're kind of grasping at nothing, or they're grasping onto this piece of technology that doesn't have anything to do with what their brain is processing as reality. So if you think of this term as embodied interaction, but if you put them in a VR headset and they get immersed, meaning they think that the virtual reality is their real reality, then whatever they're interacting with, which looks like physical objects in virtual reality, is actually an embodied interaction. They're using their virtual hand to pull a virtual lever. I just don't feel like building this whole system in real life. I don't want to make this room with all these computer systems and levers to teach them about binary counting. It's much cheaper and quicker for me to build the virtual representation, a simulation of it, but the user thinks they're in the simulation. So we can also use this idea of embodied interaction. I'm using my body to learn something abstract. So I think this plays really strongly into the fields where it's mostly abstract, like math, computer science, or what have you. Because learning abstract topics can be very hard for people, and we're very comfortable interacting, and thinking about the physical reality, our physical world. So any way you can represent an abstract topic in a physical way and give them an embodied way to interact with it, I think it grounds the knowledge. Now, this is all... there's not a lot of research done on virtual reality, and education itself always, it's anything about psychology is going to have multiple opinions because it's just such a vast and unknown field. And so I'm going to state that these are my opinions, but I can say that we have great results with teaching something abstract, the fact of binary math, how to count in a binary format and not a decimal format, how to look at a string of zeros and ones and how to convert that in your head to decimal, or an idea of a certain amount of numbers. Giving the younger students almost a play world, a illusionary physical reality where they can interface physically, pull levers, push dials, push buttons, turn dials, what have you, gives them a much stronger feedback loop. If you think about the learning loop, basically giving embodied interactions or interfacing with physical reality, which psychologically we're very accustomed to because that's our world. I think it tightens this loop super fast. And I think the more you loop on a concept of learning and practicing learning and practicing, you're refining your neural network, your neurons, their connections, that gives you these cognitions, these thoughts, helps you refine them much faster. And so this idea of embodied interaction, which is on the HCI field, I think lends itself well to embodied cognition, which is on the learning science field. But the whole idea that you can't separate the mind from the learner, you can't separate their cultural pinnings, underlyings, background, socialization needs and wants from the learner. And now you can't separate the idea of the body. You can't separate their body from the learning experience, and you shouldn't. And so you're kind of sitting in your chair, you're listening to me. It's very passive mentally. This is very passive body-wise. That's why it's not lecturing. It's not always the best way to get information across. It's just right now, we're not in a physical classroom. I can't kind of interact with you. This is the most I can kind of interact with you. But I'm just saying that embodied interactions, I think, tighten this loop because you get to practice much quicker on abstract ideas like STEM, science, technology, engineering, and mathematics. And anytime you can do a embodied interaction, and that's the benefit that my argument, basically it's my argument, my dissertation is that you can just get a better learning or better training experience by helping ground down abstract topics into physical activities to help speed up that feedback loop of learning. And that kind of relates to why the next section, why lab work helps contextualize STEM education. So physical lab work, so think of like using test tubes and beakers and doing like using the Bunsen burner in chemistry class to interacting with plants and animals and biology and using the microscope on cells, on slides that may have cells or something else, bacteria in it. To doing physical experience, like throwing the parachute with the egg off the roof, or some other type of physical experiment for physics to look at gravity, and to even doing project work in computer science classes. And that's why lab work helps contextualize STEM education. And the argument is that we've traditionally done it physically, but now we have so much advances in technology that educational technology can help replace all this lab work or supplement it. Usually a lot of this educational technology is to supplement. So in this case, we have a pandemic. We have to be at home. Well, it's a good thing we've made enough advances in technology to have videos and other types of technology that can go across the internet. And it helps ground, it helps embody abstract topics. So the same with Edtech Contextualizes STEM education. I basically just covered a lot of that. I'll let you read this at notice, but it's a lot of mixture of embodied cognition when approaching abstract concepts. And that's why educational technology is awesome. And that's the essence of my my research and my teaching and my interest and focus. And I'm going to stop it here. And hopefully that was a good grounding. I'm going to put up this video and I'm going to put up this related work section. And then we just need one more video to help ground you with the in-class activity with this bar talk card game for the week. Thank you.